So welcome back again. I am sorry I forgot to tell you that the time was getting over. Okay, and the meeting was interrupted all of a sudden. So we'll start again from where we left. I'll share my screen. This was a very important topic. How do you decide which solvent system must be used? And as I told you that we must first know this important thing, that is polar molecules or polar solvents will dissolve the polar components, okay, and non-polar solvents will dissolve the non-polar components. Okay, that is the basic information which we should have. And then depending upon what are the types of molecules we have in the sample, we are going to adjust the polarity of the solvent system in such a way that neither the sample components are going to move very fast with the solvent system, okay, and neither are they going to remain at one place on the stationary phase. Okay, there should be intermediate level of polarity of the solvent system so that all the sample components, firstly, they will move on the surface and they will not be carried very fast with the solvent system. सगळ्यांना कळतंय का हे काय म्हणतोय मी? Are you able to hear me?
Yes, sir.
Yes, yes, sir.
Yes, sir.
श्रद्धा जोशी, श्रद्धा.
Yes, sir.
हाँ, मी काय बोलला था जरा सांगता येईल का? What did I say? Because this point is very important. Okay, I want everybody to understand it. Yes. Shraddha, switch on your mic. Shraddha, can you hear me?
Yes, sir.
Okay. So what did I tell you just now?
Sorry, sir.
Huh?
I forgot. So sorry, sir.
forgot असं करू नका कारण हे सगळं तुम्हाला एक्झाम साठी आहे आणि did you know the exam date? According to the recent news which we saw in the paper, okay, of course I don't believe that that is the final information from the university, okay, but as per the news that we have seen is the exam of part 1 MSc most probably will be in I think April, okay, first week of April. Are you prepared for that? I don't know whether you are prepared, but that will be a very, very hectic job for you to study all the portion. Okay, you have 4 papers, you have 4 practicals, okay, and your teaching has just about begun right now. Okay, we could complete just 1 unit from my paper, other papers I do not know. Okay, त्यामुळे तुम्हाला खूप काळजी घ्यावी लागेल, अभ्यास लगेच करावा लागेल घरी गेल्यावर. Okay, what I'm trying to tell you here is that the mobile phase which is used for paper chromatography should be designed in such a way, मी काय शब्द वापरते बघा, it should be designed in such a way that your sample molecule should run on the surface. Okay, the run of the sample molecule should not be too fast. Okay, it should not go along with the solvent front. Okay, मी तुम्हाला व्हाईट बोर्ड वर दाखवू का? एकच मिनिट परत, कारण असं तोंडी बोलणं थोडंसं मला अवघड जातंय. ओके, आय ट्राय टू शो इट टू यू हियर. सॉरी. Okay, can you see this now?
Yes, sir.
Yes, sir. Yes, sir.
Suppose this is your plate. माझं चित्र खूप चांगले काढता येत नाही मला, त्यामुळे जे काही आहे ते तुम्हाला समजण्यापुरतं ठीक आहे असं मी समजतोय. ओके, सो ऑन द surface of this particular plate, okay, you are expecting your sample to move. Okay, this is your sample. Okay, and you are applying what is called as the solvent system. एक मिनट. This is the solvent, okay, and we are keeping all of this in a reservoir. और हे दिसतंय का सगळ्यांना?
हो सर.
हो सर.
Yes, sir.
ओके. हां, म्हणजे थोडक्यात मी काय दाखवलंय बघा की दिस इज अ कंटेनर, इट मे बी अ सिंपल ग्लास बीकर, okay, which contains your solvent system, and then I'm placing the TLC plate in the solvent system, taking the care that the that the sample spot is not getting mixed with the solvent system. हे लक्षात येतंय तुमच्या? Because if this particular spot is in contact with the solvent system, then it would probably just get dissolved in the sample buffer or in the solvent system, which we don't want to happen. Okay, so level of the solvent system is below the level of the spot. Okay, and then by capillary action the solvent system will move ahead. Okay, it will move in the ascending fashion over the plate. Okay, and as it moves along it will carry the sample spot along with it, right? Now just imagine, I'll admit Meenal. Okay, imagine that the sample components are polar. Okay, and your solvent system also is polar. So because of that, what will happen? The sample spot will move along with the buffer, okay, or mobile phase. It will keep on going along with the sample, along with the buffer. So I'll just try to show it here like this. Okay, and then at the end of the run, what will happen? The entire spot, I don't know whether I can copy this. Undo नाही का याच्यामध्ये? Okay, undo. Okay. This sample spot याच्यामध्ये कॉपी आणि पेस्ट करता येत नाही मला. Doesn't matter. Okay, just imagine that the sample spot has come here now. Okay, the entire sample has come here. It has not undergone any kind of partitioning. लक्षात येतंय तुमच्या? Absolutely partitioning काही झालंच नाही, because the sample was also polar and your solvent system also was polar. Okay, so mobile phase carries the spot till the end of the chromatographic run. Okay, so if our solvent front is here, if this is the solvent front, okay, shall I write it? Solvent front is here. Okay, this line. Okay, your sample has gone with the solvent front. There is absolutely no partitioning. The same will happen if you have a non-polar sample components and you have non-polar solvent. Again, the same thing will happen, because non-polar molecules will dissolve in the non-polar solvent. And once again, all the sample components will go with the solvent front, right? And there will be no separation. Now, on the other hand, if you have a polar molecule, okay, and a non-polar solvent system, then what will happen? I'll again try to draw it here. Okay, I am placing the sample spot here, right? And then This is the movement, this side. The solvent system which I am using here is non-polar, okay, and the the sample components are also non-polar. So once again, the same thing will happen. Same thing will happen, and again your solvent front and the spot will be together, okay, and you don't get any separation, okay, you don't get any separation, okay. इथे पण लिहू का मी? Polar solvent and polar, in right, molecules, okay. याच्यामध्ये फॉन्ट काय येतो कमी करता येतो का मला बघता येईल जरा. कमी काही होत नाहीये. हाऊ टू मेक इट स्मॉल?
You're on?
येस.
1-4.
हा मला हे याचा फॉन्ट कमी नाही करता येते. आय डोंट नो हाऊ टू डू इट.
तर ते होमच्या मेनू मध्ये फॉन्ट साईज असेल.
कुठे आहे? मला नाही दिसलं मेनू मध्ये.
हा मेनू मध्ये वरती.
मेन्यू कुठे आहे? तो शब्दच मला सापडत नाही.
नाही वरती म्हणजे कम्प्युटर मध्ये मेनू मध्ये जावं लागेल. त्याच्यात होतो फॉन्ट साईज कमी.
कम्प्युटर मध्ये कुठे मेन्यू आता येणार? आय डोंट नो, डझंट मॅटर. तर आपण काय करू, ही लाईन जी आहे ना येलो फर्स्ट लाईन, तिथे मी लिहिलं पोलार सॉल्वंट अँड पोलार मॉलिक्युल्स. पुढच्या याला मी लिहितोय नॉन पोलार सॉल्वंट अँड नॉन पोलार मॉलिक्युल्स. Hopefully you will understand what I am trying to say. ओके, हे मी इथे दिलंय. ओके, आता इमॅजिन करा की आय हॅव अ थर्ड सिच्युएशन. ओके, आय एम स्पॉटिंग द सॅम्पल अगेन, राईट, अँड दिस टाइम I am again carrying out this run. Okay, the solvent front is moving here till this point. Okay, and this time what I am doing is I don't have a highly polar, completely polar solvent as well as a completely non-polar solvent. So it is intermediate between polar and non-polar. Are you all getting what I am saying? I have a solvent system which has intermediate polarity. It is neither too polar nor it is too non-polar. Okay, when that happens, then the sample components will move. Okay, one sample component here. Okay, another component maybe here, and third component. Can you see the different components which are getting separated? Why they are
Yes, sir.
separated? Why they are getting separated? Because they are getting partitioned between the stationary phase and the mobile phase. Why they are getting partitioned? Because the molecules have a certain polarity, okay, and the polarity of the solvent is adjusted in such a way that the solvent system is neither too polar nor it is too non-polar. Okay, now that is what we are actually trying to do when we use different kinds of solvent systems. right? Now, how do we decide? एक minute, I'll come back to my original screen. इथे मी काय लिहिलंय बघा. For a polar molecule, a polar mobile phase will not allow the molecule to bind at all. Okay, and a non-polar mobile phase will not allow any movement of the molecule. मला वाटतं माझा एक थोडीशी मिस्टेक झाली आहे. I have to go back to the whiteboard. Okay, इथे एक तुम्हाला असं दाखवायला पाहिजे होतं मी की just I'll try to do it. Suppose I have the sample spot here. Right? आणि इथे आता काय केलंय मी की sample components are polar असं consider करा. The sample components are polar, but the solvent system is non-polar. Solvent system is non-polar. So I have opposite polarities. Right? एक मिनिट मी सरांशी जरा बोलतोय. Dear students, there is an important announcement for you. Bhukhtar madam will engage the class at 3 o'clock. Okay, 3 o'clock, 3 p.m. So everybody will attend the class. तुमचं सगळ्यांचं जेवण वगैरे झालंय का? मी आता इथे बंद करू का जेवणासाठी तुमच्या, की 5 मिनिटं फक्त कंटिन्यू करू?
कंटिन्यू करा सर.
Okay.
Continue करा.
Okay, so they will join at 3. मी फक्त 5 मिनिटं कंटिन्यू करतोय. राईट, मला इथे तुम्हाला काय सांगायचं आहे, हा महत्वाचा कन्सेप्ट आहे आणि हे सगळ्या क्रोमॅटोग्राफीसाठी ऍप्लिकेबल आहे काही ना काही प्रमाणामध्ये. Therefore, you should be very attentive, try to understand what I am saying. Suppose the sample components are all polar and the solvent system which you are using is a non-polar solvent system. Okay, I'll again try to draw this line. Okay, yellow colored line here. Right? तर अशा केसमध्ये काय होणार आहे की sample components will not move at all. It will not move. Okay, sample is polar and the solvent system is non-polar, so there is no interaction of the sample components with the polar mobile phase. Okay, sample components will interact with the stationary phase. The stationary phase itself is polar. Sample components are also polar, so they will stick to the stationary phase and there will be no movement at all. लक्षात येते तुमच्या? आणि म्हणून आपण काय करतो की सॉल्व्हंट सिस्टीम दॅट वी डिझाइन इज डिझाइन्ड इन सच अ वे that it will carry intermediate polarity, right? And therefore the sample components will move along with the mobile phase, and then depending upon the polarity of the sample components, they will separate from each other and they will form separate zones or separate spots on the stationary phase, right? Okay.
Yes.
So now I am back to my presentation. I will change the slide. मी पुन्हा आता ती slide वाचत नाही. Okay. How do we spot the sample and how much sample is spotted? Now, as I've already told you, either we use a capillary or we can use a pipette. Okay. And approximately we can spot about 5 microliter to 10 microliter of the sample. Okay, if your sample concentration is 10 milligram per ml, for example, then you spot 5 microliters. And if your sample contains 1 milligram per ml, then you require larger quantity of the sample, it is about 10 microliter. Okay, then coming to the concentration of the sample, normally if you don't know what is the exact concentration of your sample components, then it is always preferable to spot something like 1% of the sample. Suppose you have a plant extract with you, or you have a microbial lysate, okay, cell lysate. Okay, you don't know anything much about your sample components, and it is always better to go for 1% sample. 1% means what? Weight by volume. Okay, 1% by weight of the sample. Now this sample is deposited close to the bottom of the plate, and as I told you that when you place the plate in the reservoir of the sample of the mobile phase, okay, solvent system, then the solvent system actually should not dissolve your spot. Okay, so spot should be slightly higher than the level of the solvent, right? Okay, and then what you do, place your plate in the solvent reservoir or in the container which contains the solvent system, and keep it for some time. By capillary action, the solvent system will move over the surface. It will carry the spot. Okay, after some time, you can actually see the solvent front rising on the plate. So when it reaches a certain level, say 1 centimeter away from the other end, or sometimes maybe 3/4 of the distance is already covered, then you stop your development process. You remove the plate, dry the plate either in an oven, okay, or you can just air dry your plate. And when the plate is dried, before you dry the plate, of course, you should mark the solvent front. How do you mark the solvent front? In case of paper chromatography, you could use a pencil. Okay, so here what you do is just by a needle, you scrape out a small region. Okay, scrape out a line at the solvent front. That is to mark the solvent front. Okay, if you don't mark it like that, then what will happen? After some time, you will not be able to see the solvent front, and that will be difficult for your calculation purpose. Is it okay?
Yes, sir.
Yes, sir.
Okay,
Yes,
I'll just
sir.
try to show it. If this was your solvent front, you could see it when you remove the plate. Okay, but before you keep it for drying, okay, with the help of a small needle, you just scrape out this portion. Okay, with a different color, I'll show it. Which color? Okay, brown color. Okay, so I'm just scraping out this region so as to mark the position of the solvent front. Is it right? Or you can also draw a line, a complete line you can draw to mark the solvent front like this. Sorry. Is it okay?
Okay, sir.
After that, what you do? After that, you may require to identify the spots, and then if your samples are not colored, then you would need some coloring reagent, and therefore what we usually do is we can use fluorescent based molecules, okay, and then observe it under the UV. Or sometimes what happens is when we use zinc salts, which are already there in the silica gel, okay, incorporated in the silica gel, then the spots become uh, colorless, or rather the spots become dark colored against a blue-green fluorescent background. Okay, or sometimes the most popular method is to use iodine vapors. Okay, so what we do is we add iodine to a container, and in this container we keep the plate and cover the container so that the iodine vapors are formed and the chamber is completely saturated with the iodine vapors. Okay, so what happens is iodine vapors will color all the organic molecules. We get red to reddish brown colored spots. Okay, and when the spots are visible, once again we have to mark the spots with a scraper, okay, or a needle, so that because after some time the color will vanish, okay, and then you will not be able to do the calculation part. Okay, so again you have to mark your sample spots with a scraper. If it is amino acid sample, then we can use ninhydrine for the identification purpose. Okay, so today we will stop, and we will continue tomorrow once again. If you have any difficulties, any queries, you can ask me. in 1 or 2 minutes, and then I will stop this presentation. No questions?
No, sir.
Okay, so I'll stop the meeting, and you can join Bhuktar Madam's presentation on the same link which was shared yesterday. Okay, so bye everybody.
Bye, sir.
Thank you, sir.
Okay.